Welcome. Today we're discussing GitHub Actions, a CI/CD platform natively integrated into the GitHub ecosystem. At its core, GitHub Actions function as an event-driven automation engine. It allows developers to define automated pipelines using YAML-based configuration files that execute in response to a repository event, such as a code push. Its primary function is to eliminate manual intervention in the software development lifecycle by standardizing and automating how code is tested, built, and deployed. To understand GitHub Actions, we must look at its five-part architectural history. Workflow: the top-level blueprint defined by a YAML file in the .github/workflows directory. Event: the specific trigger that initiates the workflow, such as a push, a pull request, a job. A set of steps executing to the same runner. Jobs run in parallel by default, but you can use the needs keyword to create dependencies and control execution orders. A step: an individual unit of work within a job consisting of either a shell command or a pre-built action. Runners: the infrastructure, either GitHub hosted or self-hosted, that provide the OS environment, such as Linux, Windows, or Mac OS, to execute your code. Now that we know about the components, let's look at two distinct types of workflows that make modern development possible: continuous integration and continuous deployment. First up, continuous integration, or CI. This is all about code quality and stability. Every time you push a new code or open a pull request, your CI workflows kick in. It's responsible for making sure your new changes don't break the existing code base. Some of the examples of CI pipelines are linting to keep your code style consistent, security checks to scan for vulnerabilities before they get merged, and automated tests to verify that everything still works as expected. By running these on every push, you catch the bugs early when they're still easy to fix. Once the code passes all the CI checks, we move into continuous deployment, or CD. This is the ship it phase. While CI focuses on testing the code, CD focuses on delivering it. It takes that verified code, builds your application, often in a Docker image, and automatically pushes it to your server, which could be a Docker hub or a cloud provider. It's the bridge that gets your work from your local machine to the end user automatically. Let's break down what actually happens when we move code to production using a CD pipeline. Step 1, the trigger. We don't deploy every single commit. Instead, we use git tags like v1.o.o to explicitly mark a version as production ready. This tag is the go button that triggers our workflow. Step 2, authentication. The GitHub runners need permission to speak to AWS. It safely retrieves your encrypted credentials and logs in, establishing a secure tunnel between GitHub and your cloud infrastructure. Step 3, build and push. We compile your code into a Docker image, essentially packaging your app and all its dependencies. We push the image to ECR, or the Elastic Container Registry, which is essentially our private warehouse for application versions. Step 4, update the blueprint. Now we update the task. We tell AWS, use the new image we just uploaded. We update the ECS task definition. Think of it as your app's blueprint to point to that specific new version. Step 5, finally, the deployment. We tell the ECS cluster to replace the old running container with the new one. The pipeline even waits for the service to stabilize, so we get instant confirmation that our update is live and healthy. That's the beauty of CD. From a simple git tag to a live production update, the entire process is automated, repeatable, and safe. GitHub Actions Marketplace is a centralized platform where developers can discover, share, and utilize pre-built actions to automate their software development workflows. Think of it like an app store for community-built pipelines because it provides a library of reusable extensions and portable building blocks that perform specific tasks such as setting up the environment, deploying to the cloud provider, or sending notifications. The benefits of Marketplace. One, it saves time and effort. Instead of writing complex scripts from scratch, you can leverage community contributed solutions for common tasks, significantly speeding up workflow creation. Two, consistency and reliability. Many actions are maintained by major platforms like AWS, Google, or Docker, and the open source community, ensuring that your automation steps follow industry's best practices. 3. Seamless integration. Marketplace actions are designed to plug directly into your existing GitHub workflows, allowing you to manage your CI/CD pipeline without leaving the GitHub ecosystem. 4. Highly customizable. While you can use pre-built actions as is, the system remains highly flexible, allowing you to combine them with your own custom code to meet specific project needs. 5. Large community support. With thousands of available actions, you can find often solutions to your specific pain points that others have already solved, backed by a large community of developers. Now let's look at the top 5 popular GitHub actions within the marketplace. Based on the usage within GitHub ecosystems, these are the 5 of the most essential actions frequently used in professional CI/CD pipelines. 1. Checkout. The foundational action that pulls your repository code onto the runner, making it the starting point for almost every workflow. 2. Set up Node.js. Automatically installs and configures the specified version of Node.js, essential for testing and building JavaScript/TypeScript applications. 3. Set up Python. Configures your workflow with the required version of Python, often used for data science, backend services, or scripting tasks. 4. Upload build artifact. Allows you to save files created during your workflow so that they can be accessed by later jobs or downloaded after the run. 5. Build and push Docker images, a vital tool for CD pipelines that handles building your containerized application and pushing the final image to the registries like Docker Hub or Amazon ECR. But how do we keep these automations safe? Think of security not as a separate task, but as a filter your code passes through before it ever touches production. Looking at this diagram, we treat security as a multi-layered barrier. 1. Proactive prevention. Before we even build, we use CodeQL to scan for vulnerabilities and Dependabot to keep our dependencies patched and secure. 2. Tamper-proofing. We pin our actions by SHA-256 hash to ensure that we're using the exact code we audited, preventing any surprise updates. 3. Zero trust deployment. Notice that the OIDC step at the end. We don't store static credentials. Instead, our GitHub runner requests a temporary, short-lived token to authenticate with AWS. By running these checks through branch protection, we ensure that if any vulnerability is found, the gate stays shut and nothing reaches production until it's verified. Thank you. This is my presentation for GitHub Actions.